what is Big Bang Theory? Who discovers Big Bang Theory? This question is making lots of scientists angry. But before we can answer who discovered the Big Bang Theory, first we have to answer what is Big Bang Theory? The Big Bang Theory is the prevailing cosmological model for the universe. According to this model, the universe started from an extremely hot, dense state and then expanded outward. In other words, our universe began from a single point, which then rapidly expanded in size, eventually leading to the formation of all matter and light as we know it today. The idea that our universe started from a single point has been around for quite some time. However, the inclusion of expansion into the equation was the key component that really made the theory of the Big Bang take off. The most common misconceptions about the Big Bang Theory is that there was a massive explosion. There was no explosion. There was expansion. All the energy and matter that is in the universe right now was packed into a very small space. And at some point, this area expanded so quickly that it beat the speed of light. It did not explode. It expanded. The speed at which it expanded was faster than the speed of light. This is the reason why no light could escape this event. If anything could go faster than the speed of light, it would be the expansion of the universe. So how could we even know such a thing happened? And to answer this, let us go back to 1927, when the Belgian scientist named Georges Lemaître presented his model of the expanding universe. Lemaître was the first person to develop a model of the universe that accounted for the concept of expansion. He used data collected by Edwin Hubble to formulate his hypothesis, which he called the primeval atom. Lemaître's theory suggested that the universe began as a single point with infinite density, similar to a hypothetical atom, and then expanded outward over time. However, unlike the modern Big Bang Theory, Lemaître's model did not account for the observed redshift of distant galaxies, nor did it incorporate the cosmic microwave background radiation, which provided further evidence for the Big Bang Theory. Then, in 1931, Lemaître revised his theory to incorporate the new data and proposed a new model, which he called the Big Bang. This new theory suggested that the universe had originated from an initial singularity, an infinitely dense and hot state that had expanded outward over time. Lemaître supported this idea with mathematical equations derived from Einstein's theory of general relativity, which described the evolution of the universe from a state of high density and temperature to the universe as we know it today. However, it wasn't until 1948 that the term Big Bang was coined by the American astronomer Fred Hoyle. At that time, Hoyle was strongly opposed to the idea of the expanding universe. He believed that the universe was static and infinite, and he referred to those who supported the Big Bang Theory as Big Bang. Interestingly, Hoyle himself contributed to the development of the Big Bang Theory through his research on nucleosynthesis, the process by which elements are formed in stars. His work helped to explain how the observed abundance of light elements such as hydrogen and helium could be accounted for if the universe had indeed begun with a hot, dense plasma. So, why do people get angry when asked this question? Well, because they think that Lemaître is the one who discovered the Big Bang Theory. But actually, Lemaître came up with the theory of expanding universe, and then later on, he revised his theory and called it the Big Bang. And the name Big Bang was given by Fred Hoyle. So, actually, no one person discovered the Big Bang Theory. It was more of a gradual process that involved the contributions of many scientists building on each other's work over a period of several decades. In addition to Lemaître and Hoyle, other scientists such as Einstein, de Sitter, Robertson, and Walker also made significant contributions to the development of the Big Bang Theory. However, the discovery of the cosmic microwave background radiation in 1964 by Arno Penzias and Robert Wilson provided the most compelling evidence for the Big Bang Theory and helped to solidify it as the prevailing cosmological model for the universe. As we mentioned earlier, the theory suggests that the universe began from an extremely hot, dense state and then expanded outward. Over time, this expansion caused the universe to cool, leading to the formation of atoms, stars, galaxies, and other celestial bodies. According to the Big Bang Theory, the age of the universe is approximately 13.8 billion years. This age is based on the observed rate of expansion of the universe and the assumption that the laws of physics have been constant over time. By extrapolating backward from the present state of the universe, scientists have been able to estimate the age of the universe at the time of the Big Bang. It is important to note that the Big Bang theory does not attempt to explain the origin of the initial singularity or the conditions that led to its formation. It simply describes the evolution of the universe from that point forward. Despite its success in explaining the observed properties of the universe, the Big Bang theory is not without its limitations. One of the main challenges is that it cannot explain the observed distribution of matter in the universe. Additionally, the theory has not been able to fully account for the accelerated expansion of the universe, which was discovered in the late 1990s. These are some of the ongoing debates and research areas in cosmology. As scientists continue to refine and improve our understanding of the universe and its origins. Even though the Big Bang theory is widely accepted in the scientific community, there are alternative theories that attempt to explain the origin and evolution of the universe. One such theory is the steady-state theory, which was proposed in the 1950s. This theory suggested that the universe had no beginning or end, and that it was in a constant state of flux, with new matter being continuously created to maintain a constant average density. However, the steady-state theory fell out of favor in the 1960s after the discovery of the cosmic microwave background radiation, which provided strong evidence for the Big Bang theory. Another alternative theory is the eternal inflation model, which is based on the idea that our universe is just one of many universes that are constantly being created. This model is rooted in quantum mechanics and the concept of eternal recurrence, and it suggests that the process of inflation, which is the rapid expansion of the universe in the first few minutes after the Big Bang, never stopped. Instead, it continues to occur in different regions of the multiverse, giving rise to new universes and new matter. While these alternative theories are intriguing, they remain largely speculative and have not been supported by any direct evidence. The Big Bang theory continues to be the dominant cosmological model and the best explanation we have for the origin and evolution of our universe. Now, you may wonder, what evidence do we have that supports the Big Bang theory? There are actually 3 pieces of evidence that support this theory. The first piece of evidence is the redshift of distant galaxies. As Edwin Hubble discovered in the 1920s, distant galaxies are receding from us, and the farther away they are, the faster they are moving. This observation can be explained by assuming that the universe is expanding. If the universe is expanding, then the distance between galaxies increases over time, causing the light from distant galaxies to be stretched and shifted towards the red end of the spectrum. The farther away a galaxy is, the faster it is receding from us, and the greater the redshift will be. This observation is consistent with the predictions of the Big Bang theory. The second piece of evidence is the cosmic microwave background radiation. In 1964, Arno Penzias and Robert Wilson discovered a faint glow coming from all directions in the sky. This glow, known as the cosmic microwave background radiation, can be explained as the remnant heat from the Big Bang. According to the Big Bang theory, the early universe was extremely hot, and as it expanded, the universe cooled and the light waves were stretched, shifting the radiation to longer wavelengths. This is consistent with the observed properties of the cosmic microwave background radiation. The third piece of evidence is the abundance of light elements. The Big Bang theory predicts the relative abundance of light elements such as hydrogen, helium, and lithium in the early universe. These elements were produced through a process known as Big Bang nucleosynthesis. This process occurred in the first few minutes after the Big Bang. When the universe was extremely hot and dense, the theory predicts that the relative abundance of these elements should match the observed values, and this is exactly what has been found. These 3 pieces of evidence provide strong support for the Big Bang theory, making it the prevailing cosmological model for the universe. In conclusion, the Big Bang theory is the best explanation we have for the origin and evolution of the universe. It is supported by evidence such as the redshift of distant galaxies, the cosmic microwave background radiation, and the abundance of light elements. While alternative theories exist, they remain largely speculative and have not been supported by any direct evidence. The Big Bang Theory has helped us to understand the vastness and complexity of the universe, and has led to many technological advances that have benefited humanity. As we continue to explore the universe and make new discoveries, our understanding of the Big Bang Theory and the origin of the universe will continue to evolve. Thank you for watching this video. If you like this video, please hit the like button and subscribe to the channel. And also, we have recently started a podcast. The link is available below. Thank you for watching.